excited to be here. It's really exciting. At the Space Center in Houston.
Part of human spaceflight operations for the past 50 years. It is here that history is made and will continue on as the men and women of NASA push the boundaries of exploration.
You are now leaving the museum and entering the Lyndon B. Johnson Space Center.
Alright everyone, let's talk about what we're looking at here. This is a full-scale mock-up of the International Space Station, and it's an extremely important trainer for all astronauts regardless of nationality before they go up to the space station. It has two very fundamental purposes. First of all, this is where they learn basically the location of everything that's on the space station, and then also do some of their very basic training on big problem when you try to maneuver when you're up on orbit, and that's because of what's called orbital dynamics. Nothing travels in a straight line. If you were about 100 feet from the space station and you tried to use a thruster just to go straight to it, you would miss. It takes a series of very intricate maneuvers to get there, and this is what the trainer allows them to do. So there's what's called a docking ring or adapter that's attached to that blue cross piece that has the tarp over it, so we can't see it at this moment. And then it's even used on the space station now. When unmanned cargo ships come up, they just park it very close to the space station, and then they use that arm to grab it and then very safely dock. Now this is much larger than the ones that are up on orbit, and that's because this one does have to be able to hold itself up with the weight of gravity and also whatever objects are being manipulated. Anytime they're doing construction work on another planet that has very little atmosphere, the slightest accident that could damage a suit could end up with them dying a very painful death. So the idea is we send robots or parts ahead of the astronauts so that they assemble it. And then once it's assembled, they can test it, make sure it's ready for human occupants. Now, in order to do that, there's another problem, which is that it can take as long as 12 minutes for a signal to leave Earth before it's received at Mars, and then a return signal will also take that long. You cannot be telling a robot every little thing that it has to do and have that kind of time lag. So the robots have to be capable of what's called autonomous operation. So as I was saying, they have to be capable of autonomous operation, which is another way of saying that they have artificial intelligence. What we have to do, and this is what they develop here in this building, all the methods and the equipment that it takes to not only for astronauts, of course, to live and survive, but also to perform their missions. Now, we
currently flying the International Space Station. The one that we will be going into is used to not only train controllers for the International Space Station, but will also is in the process of being configured for the upcoming Orion space flights.
Okay, I have
entire thing will not move until that is the only thing that's left, and then that also will attach to that in some of it, and then that falls off. Pick me up, please.
Yeah.
So then you see that thruster over there? That is also the cassette. That's part of the cassette. Right there. Set. Behind there. Follow me. So let me show you guys. Man module. That's the man module. That was the set module up in there. Command. Then that was off. This the cone sheet is onto that. So then those thrusters propel it like that, and it turns like that. And then so that's already going, and that turns back around, hits the set, and then goes away onto the moon. Good little astronaut. Oh, the silver thing is open. We're in one of the usual buoyancy labs. There's 3, but this is the one that we're going to. In the water up in space. information, so that we're signing off.